And a lot of this work, there's a lot of work being done in SCTE in regards to this. So anyways, so if you hear SCTE35 or Working Group 5, that's all part of the SCTE activity. And the first speaker over here is David Agranoff, who is a principal engineer at Charter Communications. And I'm going to slow down reading the title. Okay. His talk is on ESNI, ESAM, and SCTE35 in adaptive streaming.
Thanks. Do I have this at the right spot? A little higher? Okay. So thanks everyone, and thanks Yasser and Alex and Ali for hosting this. This is great. Okay, so I'm going to talk about some SCTE standards. I promise it won't be as boring as standards, but there's a bunch of standards that the SCTE has put out that relate to advertising and relate to what we do here in video, not just for cable, but for IP video as well. And so I'll kind of introduce these as I go through the presentation, and I'll come back to the slides so you can we can recap later. This is actually a diagram that's on the SCTE site. So if you want to go there, you can kind of see the entire advertising ecosystem with all the different pieces, the different tiers of advertising for different distribution avenues. I'm not going to describe this in great detail, but this is kind of a whole ecosystem slide about advertising in cable, and it's on the website. So this is a real simple slide. It just shows how an MVPD works for video. We ingest, we persist, and then we distribute. So it's like a big breath of fresh air. It's for VOD, it's a very slow, deep breath, like. And then what we're going to talk about more is linear, which is like, so it's like a hyperventilation, and sometimes the persistence is very short-lived. And then what we have in the middle, which I want to talk about, is the heart, so the advertising. That's what I do, so it's near and dear to my heart. But as content comes in, we prepare it for advertising. As it goes out, we do the insertion. So also in MVPD world, we have two kinds of distribution. We have the classic QAM-based distribution that we in cable all know very well, and then we have, for us, the newer IP version. And then we have, on the other axis, this continuous, linear, dynamic, some call it live. It's not always live, but some people call it live. And then on the other side is discrete on-demand. What I'm going to talk about is more, these standards are more pertinent to linear. That's where they get exciting. And so things like ESNI, ESAM, and SCTE35 and why they're important. And I also wanted to mention that there's really two kinds of advertising that we do with linear. There's schedule-based, which is the very traditional kind of advertising, where a large national advertiser will buy a spot associated with a piece of content at a certain time. And when we sell it as an MVPD, we'll also often localize it. So that's where you get the used car dealerships and the law firms and things like that. It's typically sold based on like Nielsen ratings and how much they can anticipate getting in viewership, versus the more IP-based method, which is impression-based. You're targeting individuals, you're counting individual views. It's very web-like, and that's where most of the advertising world wants to be, where you can target very precisely. So transport stream, I just wanted to, I know you guys are all file format people, but we always start in cable with transport stream just because that's how we distribute on QAM. And it also is important for us to talk about just from the perspective of where SCTE35 comes from, which is a little data packet. So these are all packets going through. I actually have the arrow backwards. The PAT comes in first, the PMT, these are like tables of information of what that data is, and then video, audio, and then that little data packet there is where an SCTE35 message would live, and it would, and I'll describe how that works. And this is not in proportion to anything. Obviously, there's a lot more video than anything else. All right, so here's where an SCT35 Cue works. It would arrive in advance about 48 seconds before the actual event, which would be an ad insertion or possibly an alternate content event. And so it would point forward 48 seconds to a particular piece of video and say there's going to be a splice at that point. And so we're going to stick an ad in there. In traditional cable, we have something called a splicer, but we'll see how that works in IP. But we will then, as it goes out, we'll replace those video segments with ads. So we have these ads ready to go. They're sitting here in our persistence layer, and we plug them right in, and they fit nicely because we have very even 30 or 60-second markers that are spaced out there. So a little more about how SCTE35 works. If you hear ever someone talk about a type 5, that's a splice insert. It's traditionally called a command. So it's like, I command you to splice. Here's the point. In 4 seconds, do it. And so it's very narrowly focused towards that purpose. The other type is type 6, which is a time signal. It's just a point in the stream that says something interesting is going to happen here, but look at all these descriptors to find out what it is. And the area where you would use ad insertion is in a segmentation descriptor. You would describe a particular placement opportunity, it's called. Excuse me, that's called. You can also use segmentation descriptors to describe programs, networks, chapters, or breakaways. There's all kinds of interesting ways to use a segmentation descriptor to describe what's coming up in a transport stream. And there's other kinds of descriptors too. I'm not going to get into what they are, but I mean, you can sort of infer from their names what they are. All right, so let's now move to a different standard that's in SCTE called ESAM. It actually stands for Event Signaling and Management API. There's 2 components to the ESAM specification. One is the signal acquisition system. It's the thing actually working on the video. And the other is the signal decision system. It's the entity that actually knows the rules and logic that needs to be applied. So as we get these linear streams going into a transcoder, it discovers these in-band SCTE35 messages, and it asks the decision system what to do with them. And it'll get back a set of instructions. So those instructions can instruct it to replace the signal that's already there. It can ask it to condition the media. It can switch the media. So if we have like a sporting event that needs to be blacked out, it can insert a slate over top of it or replace it with a different game. And then it can also, if it's a packager that's actually creating manifests, it can mark up that manifest, and I'll show you how that would look in a typical scenario. So the decision system is the thing that actually knows what to do. It has all those instructions, and we're going to get to another standard which tells it how to know what to do and where it gets those instructions. And then the content obviously goes on to the CDN. So for conditioning, maybe everyone understands this, but and I probably have this wrong, and Chris will tell me later, one of my colleagues. But the content will usually come in with these different types of frames. I think you all know iframes, and then these bidirectional and predictive frames. This is not my expertise, but in any case, you have this point where the SCT35 is indicating that a splice needs to occur, and we're going to take out this content and put in advertising content or some other content. And so what we need to do is make sure that this point is properly conditioned to do that. So it has to end in an I or P frame, because obviously we're not going to have access to any of this information once the splice occurs. And then when we return, we need to make sure it starts with an iframe or access point, or I'm not sure the different names for it, but in any case, we want to make sure that this content is ready for this eventual splice that will happen. And that's what the transcoder is doing. So here's a client-side ad insertion flow. And here's where that ESAM messaging comes in. So the content comes in with these SCT35 cues, goes through the transcoder, does its conditioning, goes to the packager, does its manifest markup, and then it gets sent down here to the CDN, and then it goes back out to the subscriber, and then the subscriber is tasked with interpreting cues in the manifest and conducting its ad insertion. And then the ad segments are also delivered from the CDN. And this little guy, that's a traffic guy who's orchestrating this ad schedule information that's going down to this policy and rules section here that's driving the decisions about what to do with the signals. Because every signal that comes through is not necessarily a valid ad insertion point. That's why we need this policy and rules engine that's deciding for every signal what it means and what it should do. Right, so then there's server-side ad insertion. We call it a manifest manipulator typically. And again, the ingest works very much the same, but the distribution, we intercept that distribution, the manifest, and we pull out the segments that are in the entertainment content, and we stick in the segments that are the advertising. So the client has a lot less to do. They just need to play that playlist in the order that it's provided. And then the only thing the client would typically do is report metrics, that the client viewed the ad and that at different points in the ad. So the ad started, it finished, quartile measurements, things like that. And so it's the manifest manipulator who's interacting. And by the way, that ADS is Ad Decision Service. It's typically the system that knows what ad to place into the stream. So let's look a little bit about how this works in HLS. If you look at the SCT35 standard that's on the site today, it prescribes how that's done with a custom tag that's called EXTX SCTE35, strangely. And it has a bunch of attributes, including the duration, the type of cue, and then it just spells out the entire binary of the cue transformed as base 64. That's what you see there. There's typically a unique ID, and it will take effect immediately upon the next segment. So in this particular case, we're segmenting at that ad boundary. We're making sure that the packager breaks up segments so that the first segment in the ad boundary can be completely replaced. You don't have to index into the segment with HLS, and you simply replace every segment that's highlighted in blue with an ad segment. in your manifest manipulator. So as time goes on and the cue progresses and the manifest gets reconditioned a few times, then it looks like this. Now we're a few segments in, and we've added an elapsed attribute there that says we're 12 seconds into the ad break. So as these dynamic HLS manifests are refreshed, we get a view for where we are in that break. And then when we get to the end, we'll see probably a closing segment where another 35 came in to verify that the ad break has indeed ended, and then we just jump back to the regular content. So a manifest manipulator, or a client for that matter, would just replace all of these intermediate segments. So that's how the SCT35 standard said to do it. But then HLS came out as an RFC, so now there's a new way to do it, which is called the date range tag, and you heard Josh talk about that this morning. And the date range tag says, first I'm going to baseline a date and time for this manifest, and then I'm going to use that baseline to as a reference for date range tags. And the date range tag doesn't, unlike the previous slide, it doesn't have to occur exactly before the segment. It can, as long as the date range is offset by the proper amount, which it should be if I did these slides right, it's actually referring to this segment here, even though it's up at the top of the manifest, because those date range tags will trigger events as soon as the manifest is loaded. So you could theoretically reference a point in the middle of a segment, but if you're using a manifest manipulator, you wouldn't want to do that because you want to be able to remove entire segments and replace them with entire segments of ads. And then as time went on as well, you would still get these date range tags appearing at the top of the manifest. They would, just like with the custom tag, they would be indexed in to let you know how far into the ad break you happen to be at any given time. And then eventually you'll get an end signal, and so you'd have two date range tags, one for the start and one to indicate the end. And I put them all at the top just on purpose to show that they don't have to be right at the segment in the playlist. They just need that start date value to be properly calibrated to where the point of interest is. Okay, and then there's Dash. So I know more people are interested in Dash. Dash, there's also a way to do this. One way is to, as you get to an ad break, is to divide into multi-periods. And so that's where it gets a little challenging, is to make sure that, so as these, as the packager outputs this and it encounters these ad breaks, it will generate a new period. And it will, this is one way to do it, is to put the actual event into an event stream, to put the SCTE binary. This could also be broken out as fully detailed XML. So in the SCTE35 specification, it shows not only how to do this in binary like this with base 64, but to break it out in individual fields if that's more helpful. And either of those can work inside this, this signal wrapper here. And that namespace, by the way, references the SCTE35 namespace at the top. And another way to do this, of course there's multiple ways too, is an in-band event stream using the e-message box in a file format. So in that case, you would just call out an in-band event stream and that it contains SCTE35s, and it would be part of the video adaptation set. Okay, so then the other thing I want to talk about is blackouts and alternative content. And the reason is this is very much like ad insertion, but it's like a giant ad. So instead of replacing a 30-second piece of content with an advertisement, we might be replacing a 3-hour sporting event with another sporting event, or a 30-minute television show that happens to be web restricted with a slate. So in that case, we're doing what's called alternative content. It works very much the same way. It can work with the manifest manipulator, just like ad insertion does. But the important thing is that there's a standard for it in SCTE for describing all of that, called the Event Scheduling and Notification Interface, ESNI, as it's affectionately called. It's SCTE224. And it drives these rules that go into this system. So it can describe the schedules, it can describe blackout rules, and it can do it in very great detail. And it can do it in a reusable way. So some concepts from ESNI is everything, all the streams or even a VOD asset is a media. Within a media are media points, which are temporal points, which can be indicated by wall clock time or by a match signal, so an in-band signal to look at. Does that mean I'm out of time? Okay, I'll try to hurry. And then you can also describe with metadata as well. So there's descriptive metadata, just like you would in a program guide, that can be received with an ESNI feed. There's policies which go with the media points that are a collection of viewing policies, which are themselves a association of an audience and one or more actions. So you can say, for everyone in Colorado using an iPad with certain capabilities, using a certain app, I want to black them out for whatever reason. You could make up any rule that you want. Usually they would be rules around sports or rules around web embargo, and so you can create those actions. The action could theoretically be anything you want, but usually it's a blackout or a content switch. And then there's a mechanism to audit. So in the slide deck, which I'm not going to go through, are examples of how all this works in XML. So go through that and look at it later just to see some examples. These examples are right out of the standard. But that's really my overview of those relevant SCTE standards. Hopefully it all made sense and came together at the end. If you have questions about any of these standards, or if you want to get involved in defining them, we encourage you to join and work with SCTE, get in the working group. Dean is over there, Dean Stoneback, and I think there's some information as well. Does that count as a promotion since it's a standards organization?
I think so.
Okay. So that's it. Thanks.
All right. Thank you, David. All right, any questions? We'll go with Arash first.
Thank you, David.
Hey.
Do you have any use case for early terminations of ads? And if you think it's useful, how do you address it in either specs or an actual deployment?
Right. Yeah, I didn't show any examples, but that's definitely a use case that we have to be aware of in linear television. So what you would do is you would get an initial signal that said start an ad break, and then you would get a unexpected early signal that said end the ad break. And so you would have to propagate that signal through. It would propagate, from the encoder to the packager, which would insert that marker in there, whether it be HLS or dash, and then the manifest manipulator would have to react to that, or the client, and return back to the entertainment content.
Thank you, David. Very nice presentation. But I have one question. To what extent is the ad content being conditioned to the main content? So does it have to be the same codec, the same frame rate, the same color transfer characteristic, or basically, can it be mixed and matched? Because that's one of the questions we always have. How much is the ad content? Can it be different? And how much does it cause problems at the switch for the client?
Right. There is some forgiveness, so you can have the notion that they're not exactly the same bit rate, and even the same frame rate certainly can change. But ideally, if you have some control over the ad content, you want it to follow that same profile ladder as your entertainment content. So often what you'll do is the advertiser will just provide an MP4 of the video, and you will contract for some sort of, like in IPs, for some sort of real-time encoding to create the profile ladder that you want for your application. That's ideal if you want the best experience. But I don't think you'd want to switch the, there's certain attributes you wouldn't want to switch, like in HDR you wouldn't want to go between, is that what you were saying, like the transfer function?
We have all these questions about what can happen at an ad split, what do we have to prepare for? Can the codec change? Can the resolution change? Can the frame rate change? And then you have the questions it's not only the decode, it could be that the HDMI is kind of set up for a specific frame rate and it changed the frame rate, so what's happening then? So just in the ecosystem, how much do you condition the content to work with the entertainment content, or how much do you have to live with ads which are just different format and you throw in, and then all of these things happen? That's always a...
Yeah, ideally the resolution stays the same. The frame rate can change. And we have use cases where you want it to change. Like if you have a cinematic an ad for a trailer, like a trailer, sometimes those are different frame rates, and they want them to be preserved at that frame rate. So it can switch from, say, 30 to 24 or something like that.
David, you mentioned how SCTE35 messages are handled at the head end, but segmentation descriptors are equally important, as my understanding, for reporting, for audience measurement of particular content, and ad exposures. People don't get paid unless that information is reported from the client.
Right.
So I just wanted to verify that some of the examples you gave will typically kick off the reporting action that translates into dollars.
Right. What we see typically is the 35 is not used directly to report for, at least for ad usage. We'll use that 35 to trigger a request to that ad decision service, and it will return a series of beacons, of URLs basically, that they want a get to be performed on, an HTTP get that says, I reached the beginning of the ad, I reached 25% through the ad, I reached 50%, and I reached the end. And so what they expect is for the client to fire those beacons by just executing HTTP gets on. So it's not coming directly from the 35, it's been translated at that point.
It's either a program ID or an ad ID that has to be conveyed. So in the case of audience measurement, it's probably in the segmentation descriptor, but in the ad case, yeah, you've got an ad decision server that's aware.
Right.
We'll take one more question, but if I could have Matt come up. Okay, we'll get you set up too.
Is there another question? Oh.
So I just want to clarify one thing. So for HRS, the server-side ad insertion, the SCTE35 is only about to advertise so basically publish a advertisement opportunity.
Right.
When the manifest is really modified by the manifest server, the client doesn't receive the SCTE35 anymore. It just, there will be a discontinuity if the ad doesn't have the same PTS, right? So it's
That's right.
Okay.
Often there'll be a discontinuity there. That's correct in HLS. And the 35, if it's server-side ad insertion, the 35 is not so relevant anymore to the client. Instead, we get those beacons and we put those in. We say, we've already put the ad in, just fire these beacons at these different points of the video playthrough, and that's all we need the client to do.
Okay, thank you, David.
Thanks.